How you doing, Chontek here? Welcome back. All right, so what are we looking at on the right-hand side of the microscope screen right now? It looks like a big old blue, a big old, a big old whatever. There's a white ring. Actually, what you are looking at are the LED pixels of an iPhone 8 that I've zoomed into up to about 50x magnification. So these pixels that you're looking at right now. Oops, I gotta keep my phone and it's actually looking at my cell phone underneath the screen. If I start to zoom out, this shape should probably look somewhat familiar to you on here, right? That's the Google Chrome image to it. Yeesh, my screen's dirty. Everything always looks dirty underneath a microscope is what it does. But if one were to zoom in somewhat carefully using a digital zoom and hold perfectly still, you see that there are rows and rows and rows of greens, reds, and blues that all make up what the screen is actually made of, like what the little individual pixels on the screen are all made of. And as I continue to, I'm going to try to hold very still here. Nobody move. Oh, bonk. Yeah. So you can see right here that I'm going to try to, let me see if I can do anything to focus it. These are pretty hard to focus in on here. I'm going to try to do my best kind of. It might be about as good as I can get with the magnification. These are pretty tiny pixels. I mean, like, really, really small. But they essentially consist of a green LED, a red LED, and a blue LED, which make up all of the uh, colors that we potentially see, as well as the contrasted back shadow masking part of the phone that is part of it there. So I'm going to take my phone out from underneath here. So what is an LED, right? So I've kind of got down in the lower part of the screen here, hopefully down there or somewhere, is a classic example of what we would call the schematic symbol for an LED, and like your classic like electronic bleh, hobbyist kit part that may be there, which consists of an anode and a cathode. Now, in a nutshell, what an LED is a couple of things. Easily to summarize though. Number one, it is a one-way street for electricity to flow through. Most of the time, and NASA, don't you bite my face off for this, or any of the boys at MIT or whatever. There's always exceptions to every last little thing. But generally speaking, electricity flows from the plus the anode side to the minus the cathode side, and cannot flow in the reverse direction without breaking the part. This is very much just like the one-way streets that we commonly think about as roads. Cars go down one way. Sure, a car can go back the other way, but heaven help if there's another problem happening going, and and that one of them's happening at that point, But anyway, so electricity flows from plus to minus. The more electricity that flows through an LED, the brighter it gets. It takes a little bit of some electricity, what we call voltage, which is the force that allows electricity to pass through. It takes a little bit of a voltage to get it to turn on. You could think of it kind of like a toll for the tollway. You pay a little bit of the toll, and the rest of it, you just fly down on the way. And the more electricity, the more current that passes down through the LED from anode to cathode, the brighter the LED happens to get. And so for most cell phone screens, LEDs just happen to be combinations of red, blue, and green LEDs compacted up together in a very, very tight space. Now, what I actually have to put underneath the microscope right now here is an RGB LED. Now, let me zoom out so I don't have so much digital zoom here. Okay, so you can all kind of see what I'm looking at here. I'm gonna kind of bring this into a basic focus. Okay, so this thing, which by the way, this little guy, I'm gonna pick him up and just kind of, hey, there he is. You see him there? Huh. That's the top side, and there's the bottom side of it here. This thing is not all that big. It's probably about 3. Well, where's my scale? Let me. All right, so let's pull out the old scale of Rooney. There he is, the scale of Zoopster. And there you got them on there. So now we'll kind of move them into place. This thing is approximately, say about 3.5 millimeters by 3.5 millimeters, somewhere around there. Well, no, let's go down to inches, because maybe there's an inch thing. Nope, it looks like it's, oh, let's see, 3, let's see, 1, 2, 3, 4, 5, 6, 7 64ths. Is that a measurement? I don't know. Yeah, so it's about 7/64 is what this happens to be according to the scale. But what this actually is, if I turn it upside down, one will notice that there are actually not one, not two, but 6 prongs that are on the back of this guy. Can you all see that? Okay, I'm gonna turn on the light just a little bit here, dim things down a little bit. Get in the mood for some LED dimming. Yeah. So yeah, you have 3 prongs on each side. 3 of those are what we would call the common cathode. Actually, and I don't even know if these are truly a common cathode, but they are all a cathode. So one of these sides, all 3 of them, is the cathode, and on the other side, it is the anode. Is what it is. So each one of those. Now we can actually test this out by using what we would call a digital multimeter. Now I'll be using a Fluke 87- Roman numeral 5, an 87-V for mine. So you want to set this to the indicator that looks like the LED symbol. In fact, I'm going to put this underneath here, excuse me, LED, boof, excuse me about that. So you want to set this to that symbol right there. You see that? I'm rotating the little switch in. See that there? See that? I'm rotating a little switch. And what this little guy does, this is used for testing out diodes and LEDs, but for LEDs, this kind of performs a neat little function, is what it does. By putting the red probe, if you will, on the anode and the black probe, if you will, on the cathode, we'll actually get the LED to light up just a little bit. So I'm going to turn down the lights, and I'm going to touch the sides of this here. And you might be saying to yourself, how does he know which side is which? And there's one side. You see that? There's the blue popping on. There, the green is in the middle. And the red is up on top. Blue, green, and red. So inside the LED are 3 different die, red one at the top, green one in the middle, and blue one down at the bottom of it, that are all used to basically connect up the LED. Now, I was actually having a little bit of a problem testing out the LED using my my probe tips that's with it on here. So I have kind of a dummy circuit board, if you will, that I'm going to kind of bring over here. That's got a big giant metal pad that's sitting down to it right there. You see that big old pad? That is a big honking pad. What I'm going to do is, and I'm going to try to do this, I'm going to try to essentially do this at somewhat of an angle here. So maybe you can have a chance to be able to see this. I'm going to take the LED, and notice that if one were looking carefully enough, at that LED, that the one corner of the LED, one corner of that LED is notched. Can you see it on there right now? Can you see it there? It's in the lower left-hand corner of the LED. There is a notch right here. That notch for LEDs typically tends to indicate the cathode. Not every time, but typically tends to indicate that there's a cathode there. So what we're going to do is I'm going to take some solder, and I'm actually going to solder all 3 of the cathodes together, just making it a little bit easier for me to be able to attach a probe down to just one spot, and also to help mechanically fix it into place. Let me move this up a little bit right here, so potentially you get a little bit of a better view. I'm going to take my light source here and try to get as a good a view as I can potentially get here. I don't know if this is actually going to help out. There we go. All right, so we got ourselves a little bit better view. Can you all see that okay here? Okay, so I've got my LED at this point sitting on there. What I'm going to do is I'm going to apply a small amount of some fluxing agent using a syringe tip that I happen to have here. Small amount of this material. Now what this material does, it's going to help clean the surface, allows for solder to flow down onto that surface a little bit easier. Now I've got my soldering iron in my hand here and my solder wire here in my other hand, so underneath the microscope it's a little bit easier to see. Solder wire and soldering iron. What I'm going to do is I'm going to touch the soldering iron to the flux. That generates just a little bit of some fumes. And now what I'm going to do is I'm going to touch the solder down to it, and it's going to flow, literally flow on top of that LED and actually connect up to all three of those parts. Did you all see that? Did you all see that? So at this point, what I've got right now is I actually have all three of those parts are actually connected to each other. You see that? Can you see that? I don't know if you can see that. Let me bring up the contrast just a little bit more. And all three of those are both physically and electrically connected together in union of one big honking pad. Yeah. So, all right. So now we come back down to, okay, now we're back to my normal vision without my glasses on. Okay, there we are. So now at this point, what I've got is I've actually got just one big pad to put my my black probe down onto, the negative probe. And the other three pads are actually kind of sitting off to the left. I'm just going to touch them one at a time with the probes from my digital multimeter. This makes it easier. Number one, it makes it easier for me to just put the probes down on top of the thing. Number two, it also makes it to where I can more or less just simply you know, well, put the black probe down on top of the large metal pad at this point, so I don't have to worry about that. And two, it's the solder is actually holding it into place. It has melted on both the pad as well as the part, which electrically and physically connects them together. The physical part is the more important one. It's physically holding a rather small part into place. So I'm going to come down here with the black probe, and I'm digging the black probe down into the solder. You can see that the blue comes on, green comes on, and the red comes on. If I am careful enough, I might be able to get all three of them to possibly turn on. Maybe? It's somewhat, it's doing it a little bit right there. There's the blue and the, no, it doesn't seem like it wants to do this here, and I don't know if that's just me. I thought I'd actually would be able to potentially dig my way into there. Let me try one other thing. I'm actually touching the soldering iron to the tweezers. It doesn't look like I'm able to turn each one of them on simultaneously with it right there. Oops, and my board is slowly but surely sliding away from me right there. But you can see though, this is kind of a cool thing. We get the blue to pop on, and I just noticed that. So let me dim down the exposure just a little bit more, and we'll dig down the gain on here as well. In fact, here, let me switch hands because I am a right-handed person. I am right-handed, so I do most of the finer pitch stuff with my right hand. Now let's see if we can actually get the individual dies to show up in there. This is not always, it's sometimes easier said than done. There's the blue one, there's the red one, and the green one is there in the middle. I'm going to try to darken it down again here, just so, see if I can get the actual LEDs. These LEDs are being tested pretty brightly. There's the blue, there's the green, and there's the red inside of this, which if you were to look at this just, you know, coming from an outside point of view, I mean, I'm gonna try to not stab myself on here, you know. So here's the, you know, there's the green. This is actually pretty darn bright to be able to show. This is just like some, you know, regular old you know, just power with it right there. So, but in the end, the LED this winds up really being in the end how all LEDs truly are. In terms of how they work and how they function, especially on screen. So anything that's got like this term that's like OLED, anything in general, this tends to be like kind of how they work with it. Current flows from anode to cathode, and then red, green, and blue combinations of the different colors of them actually make up a majority of the other colors. Now we've actually got at some point, I've got a circuit to build, which actually we designed as part of our college, maybe like 2 years ago, maybe a year ago, something like that. And we got a board that when you press the different buttons down, it activates each one of the colors individually. And it's some pretty nerdy stuff, is what it is. So we'll potentially have some time. If we got time on here, we'll build one. Let's build one slowly. We'll do it as part of a neat little event to show how that's done. But yeah, I wanted to kind of showcase a little bit about what the LED is, the RGB in particular. This is an RGB, red, green, blue LED in terms of how it works, and the fact that it's everywhere. I mean, it's in screens, it's in phones, it's in cars, it's in it's all over the place. So that is a cool. Oh, sorry. I mean that down there. I have to look at the camera. I was actually really pointing at it. I'm down trying to point it on the screen. Right. So the LED is actually kind of a pretty cool thing, is what it is. So all right. Thanks for tuning in to Chontech. Let me know if you got any ideas or anything like that. Or anything floats your head. Do you think this is cool? Do you think this is terrible? Would you like to see something on there? Do you have suggestions to it? Do the YouTube thing of like, comment, subscribe. That's what they say, right? I don't know. I'm new at this whole game. I don't, you don't have to if you don't want to. Whatever with it. Yeah, say whatever you want to. All right, but this is Chonteg, and hey, we'll see you later. As soon as where is the thing? Oh, there's